Good morning, everyone. In this video, we will be finding out how the periodic table was created, its parts, and some elements from it that we can extract information from.
Before, when the periodic table existed, several scientists tried to arrange the known elements during their time according to their properties. But the main person who composed the periodic table we know today is Dmitri Mendeleev. He first attempted to arrange the elements based on their atomic mass and atomic properties at the same time. But because it wasn't accurate, he tried to arrange it based on their atomic number. And with that, he was able to make the periodic table. He was raised in a poor family and his father had died when he was still young. His mother opened a factory, hopes to send Mendeleev to school. However, it burned a year after, so his mother traveled a long way with him to a university in Moscow, where he was sadly rejected, then to St. Petersburg, where they finally accepted him.
Elements in the periodic table can be separated based on their physical properties, and they are separated into metals, nonmetals, and metalloids. Metals are shiny, malleable, and good conductors of heat and electricity. Nonmetals are dull and poor conductors of heat and electricity. Metalloids have properties in between metals and nonmetals. They can also be separated based on their groups. They are separated into main group elements, transition metals, and inner transition metals. Main group elements are further separated into the following.
Number 1. Alkali metals. These elements are found in the group 1 of the periodic table and are very reactive as they want to remove the one electron in their outermost shell to achieve noble gas electron configuration for stability. Number 2. Alkaline earth metals. They contain elements from group 2. They are somewhat reactive but not as much reactive as the alkali metals. Transition metals contain elements in groups 3 to 12. These elements are at the center block or D block of the periodic table and are fairly unreactive. They are great conductors of electricity, malleable, and important in chemistry. The halogens, or those elements in group 17, on the second to the rightmost column of the periodic table, love to react with alkali and alkaline earth metals.
The inner transition metals include the lanthanides and the actinides, which are both found at the bottom part of the periodic table. Lanthanides are all metals with reactivity similar to group 2 elements. Actinides are all radioactive elements. Noble gases, located at the rightmost side of the periodic table, are completely unreactive. The metals, metalloids, gases, and nonmetals characterizing groups 13 to 16. They don't usually react and tend to be boring except in more advanced and broader topics. However, they are still vital for life. Within this jumble is the boron family that is found in group 13. Next to it is the carbon family in group 14, followed by the pnictogens in group 15. Completing the jumble are the chalcogens that are located in group 16. This is the periodic table with all the parts in one screen.
Next, we will look at 5 elements in the periodic table and how they were discovered. Number 1. Cobalt. It was discovered by George Brandt in 1735. Since one effect of cobalt was its oxide with colored glass blue, initially it was thought that the color was due to the presence of bismuth. However, he was able to isolate cobalt from bismuth, discovering a new element previously unidentified. He named the new element cobalt, which comes from the Greek word cobalt, referring to a goblin. Number 2. Technetium. It was discovered by Emilio Segre in 1937 in Italy at the University of Palermo, along with his colleague Carlos Perrier. He discovered it from a molybdenum foil that had been part of the deflector in a cyclotron that Ernest Lawrence mailed to him after asking him to. He then succeeded in isolating the isotopes of the element 43, the now called technetium-95 and technetium-97, from the molybdenum foil, proving that the molybdenum activity was coming from there. The element discovered was named after the Greek word for artificial in 1947. Number 3. Tellurium. It was discovered by Franz Joseph Müller von Reichenstein in 783 at Sibiu, Romania, from an ore that had the metallic sheen. He suspected that it was due to antimony or bismuth, but after investigating the ore, he failed to find either of them present. He then reviewed the ore and discovered that it contained a new element not yet known. He then published his findings on it, and in 1796, he sent a sample to Martin Klaproth, who had already received a sample of the same element from Palke Tybel. Palke Tybel also discovered tellurium independently. Klaproth confirmed his findings and afterwards named it tellurium.
Number 4. Titanium. It was first discovered by Reverend William Gregor in 1791 in Cornwall, after recognizing the presence of a new element in ilmenite in black sand in a stream. He noticed that the sand was attracted by a magnet, and soon found out that it contained two metal oxides, iron oxide and another which he could not identify. That identified oxide contained a metal that was not yet known at that time, so he reported his findings. However, he was not the only one who discovered the element. Franz Joseph Müller von Reichenstein also produced a similar substance, but he could not identify it as well. In 1795, Martin Klaproth also discovered the oxide independently in rutile from a village in Hungary, and found out that it contained a new element. He named the new element after the Titans of Greek mythology, thereby getting the name titanium. Then, in 1797, he heard about Gregor's earlier discovery and found out that it also contained the element he had discovered, titanium, after obtaining a sample of manacanite. Finally, number 5, thallium. It was discovered independently by William Crookes and Claude Auguste Lamy in 1862, both using flame spectroscopy, which is used to determine the composition of minerals and chemical products. William Crookes used this method to make spectroscopic determinations for tellurium on selenium compounds, and soon he noticed a bright green light in the spectra of the sample of selenium, and concluded that a new element was present. He named the new element from the Greek word thalos, meaning green shoot or twig, because of the bright green spectral emission lines that the element produced. Then he was able to isolate small quantities of the new element, and in the process determine the properties of some compounds. At the same time, Lamy also discovered thallium by using a spectrometer to determine the composition of a selenium-containing substance which was deposited during the production of sulfuric acid from pyrite. He also noticed a bright green line in the spectra and also concluded that a new element was present. He was also able to isolate the new element thallium from the substance. There was a feud between Lamy and Crookes on who should get the credit for discovering thallium. Both got awarded, but to this day, Crookes gets most of the credit for discovering the element.
Now let us look at another 5 elements in the periodic table and discover their uses in our daily life. Number 1. Sodium. Despite being reactive, it has a lot of uses. When combined with chlorine, it becomes salt, which we use to season our food to a taste. Sodium also helps balance fluids and electrolytes in the body. Liquid sodium is used as a coolant for nuclear reactors, and sodium vapor is used for making street lights with a yellow light. Number 2. Copper. It is used for electrical wires. It can also be made into coins, which are sometimes combined with other metals to form alloys. It is also used in the Statue of Liberty. It is a good conductor of heat, and it is also necessary for the life of plants and animals since they use copper for their survival. Number 3. Calcium. It is for healthy bones and teeth. It is also placed in toothpaste, used for muscles to move, used to make mortar and cement, and is also used to carry messages through the nerves. Calcium is also the one making the wonderful stalagmites and stalactites in caves. Number 4. Gold. It holds the key to pretty much all kinds of rich stuff, like jewelry, coins, ornaments, signs of economic status, and monetary exchange. Gold is also used in small amounts in our gadgets and sometimes used in space to deflect the sun's light. Number 5. Chlorine. It is used a lot, especially when combined with other elements. Examples of such are toothpaste, production of nuclear material, insulation of electric towers, etching glass used to make plastics, dental products, and Teflon. In its pure form, it can also be used to set things on fire.
The periodic table is a huge breakthrough in the field of science. It's neat, important, and has all the elements that we know today, thanks to the sacrifices of Mendeleev, his mother, and other scientists who helped both indirectly and directly to the periodic table. From their sacrifices, we can see that each person has the ability to make a difference in the world, regardless of a race, gender, etc.